The Malaysian palm oil industry is the one of the nation's major revenue earners, and it is the second largest producer globally after Indonesia. Malaysia producing approximately 40% of the total crude palm oil in the world. The success in palm oil production also meant production of large amount of agricultural wastewater, namely the palm oil mill effluent, also commonly called POME. Most mills have adopted ponding system and open lagoon method for POME treatment. As pressures mount due to environment protection and public health concern, the enforcement authority started to tighten the discharge quality to more stringent limit. Greener and more sustainable technologies are highly sought by all stakeholders. The palm oil industry produces some major byproducts in the form of solid, liquid, and gases, which theoretically can be raw materials for many downstream production activities. Otherwise, they are called the waste, which may be sources of major environmental problems. Some of these byproducts have been used to create further economic return to the millers. For instance, palm kernel shell and mesocarp fibers are commonly used in mills to fuel the boiler to produce steam and electricity for process use. Palm kernel cake is feedstock to animal feed production. The remaining waste pose as burden to the millers. POME is a major source of pollutant to rivers or water source due to its high organic content. Empty fruit bunch is a major underutilized biomass waste. Other wastes include sludge, decanter cake, and frond.
Hello, my name is Dr. Judon from the Faculty of Engineering, UMS. Thank you for watching this video. This is my great pleasure to introduce what we are working on in UMS. Right now in my lab, we are trying to contribute in the palm oil industry in Malaysia. As we know, palm oil industry is one of the largest crop, and we generate incomes from the sales of the oil as well as from the secondary product derived from this industry. At the same time, we realize the existence of problem associated with this industry. For instance, the discharge of palm oil mill effluents, as well as the redundancy of empty fruit punch. So typically what the industry or the researchers are trying to do, they try to overcome the POME problem by improving the wastewater treatment. For instance, many have studied the use of good microorganisms, and some use chemicals to treat the pollutants. But in our group, we use a different approach. We realize that the pollution comes from the existence of oil, and at the same time we realize that that oil actually is money. So the challenge here actually is, if we can remove the oil, we can actually reduce the burden in the wastewater treatment. So in the lab, what we're trying to do is we are trying to develop a technique that is capable of absorbing the oil, therefore the BOD and COD of the effluent can be reduced, and at the same time this technique is able to recover the oil, and that oil can be pre-treated before it can be recycled back as CPO. And the second project that we are trying to do in the lab is we are trying to improve the existing empty fruit bunch. Currently, empty fruit bunch is used as a fertilizer, and there are many attempts to use this for secondary products. But oftentimes the application is limited because empty fruit bunch contains oil, and the current technique is using techniques such as solvent extraction, often not as good. Furthermore, this technique is actually environmentally not friendly because solvent itself is toxic. So we try to use a different approach. We try to capitalize on the thermodynamic property of oil as well as the water. Third student is actually we try to find the additive values of the oil recovered from POME. So we try to produce products such as biodiesel as well as lubricants. So in this project, we try to synthesize a good catalyst that is capable of converting a low quality feedstock such as the oil derived from palm. And yeah, check it out. The students will explain more.
Nanofiber is an emerging technology. Its potential in oil sorbent, in oil spills control and clean up in submarine industry shows the potential in oil recovery from palm oil mill industry. As palm is consisted of 100% of oil, thus it is very toxic to organisms living in aquatic. Hence, polypropylene nanofiber helps to absorb oil from palm. Nanofiber is super oleophilic and hydrophobic. It is excellent in absorbing oil even at emulsion form. Preliminary results show that 1 gram of nanofiber able to recover 28 grams of pure oil and 20 gram net weight of oil can be recovered via manual pressing.
EFB comprises of approximately 3 to 4% of oil by weight. Conventionally, the solvent is used to recover or to remove the oil. This technique is costly and is not that effective.
In my research, I use a totally new approach. I use the thermodynamic property to remove the oil from the fiber. I hypothesized that if I cool down my sample at the correct temperature, I can easily remove the oil from the fiber. Right now, I'm at the beginning of my work, so wish me luck!
The oil recovered from palm in EFB can be converted into available products such as biodiesel. We have developed a novel carbon-based catalyst derived from rubber tree leaves that has excellent reactivity on production of biodiesel. The catalyst comprises of high density and functional groups, high thermal stability, and it has porous surface. By using the catalyst in esterification of oil from palm and EFB, the biodiesel yield obtained is high.
Hi, my name is Chong. I work in industry for 20 years. I believe there are better way to deal with the palm oil waste management. One of it is actually recovery of oil from palm. By doing that, it serves two purposes. First, to recover the oil which is of economic value. Secondly, is actually to reduce the organic load of the palm.
So we are quite lucky in this university because we've got several funding to do this research. One is we have Newton Fund. We are collaborating with the University of Hull to do this project, and we've also received sponsor from a company because they are very much interested in having faith in the work that we are doing. And last but not least, our beloved UMS is also sponsoring this project. So thank you. It's my excitement to tell you that we are on our way to solve this problem, and you understand what we're doing, and so that at the same time you can come forward to be a part of these awesome projects, as well as if you are from the industry, you can come and see, have a look. Probably you can invest so that you can be a part of the products down the road. And if you are potential students that you are looking for good projects, if you are have that quality, then you are most welcome to approach us at any time. Thank you. It's my pleasure, and enjoy the rest of the day.